All right, so to start off the muscular, or to continue the muscular unit, we're going to talk about motor units in this lecture. So here are four outcomes for this lecture, and most of this, if not all, should be reviewed, but it's always good to review. All right, so what is a motor unit? Well, as you can see in the picture, maybe, um, and I apologize if it's blurry, never noticed that before. A motor unit is one neuron and multiple muscle fibers. So in this picture here, we've got two motor units. So the purple one that's innervated looks like two fibers, and the red one that's innervated three fibers. Now it's important to know that a single muscle is made up of multiple motor units. And so when a contraction occurs, we're not activating all of the muscle fibers or all of the motor units. Okay. Now, type 1 fibers are smaller motor units, and we'll get into some differences here in a little while. And type 2 fibers are larger motor units. So type 1 don't generate as much force compared to type 2. Now, when a motor unit is activated, um, in other words, if it reaches threshold, it'll activate multiple fibers, like it said previously. And when a motor unit reaches threshold and has an action potential, these muscle fibers will fire maximally. There's no like halfway doing things. Now, the force that they generate can be altered, but it depends on other factors. But no matter what's going on, they're going to give their all, right? And so there are conditions where their all will be a little bit higher or a little bit lower. And so if we want to have maximal muscle contraction, then we need all motor units to fire at the same time. And to be clear, this doesn't really ever happen. It's difficult, if not impossible, to actually activate every motor unit in a muscle. We can get close, especially those that are trained, like weightlifters and stuff. Some of those can get really, really close, but without external stimulation, it's basically impossible. Now, when we recruit motor units, this is based on the size principle, so they're recorded in order of size. So we recruit smaller ones first and then the largest ones. And this allows us to conserve energy and be efficient. And so if I'm only using something that doesn't, or if I'm only needing something that I'm doing something that only requires a little bit of force, there's no sense in recruiting my largest motor units. Okay? And the way that this is done is that these motor units each have different thresholds. And so if you just, instead of where this says tension, just think of this as voltage, threshold voltage. Okay? So notice that the threshold is this line right here. We're going to recruit the small motor units first, and then as the stimulus gets bigger, we're going to be able to recruit these second set of motor units, and then third, when we have a big stimulus, we'll recruit those maximal, those largest fibers. Now, the strength of contraction, the strength of force that's produced, is affected by a lot of things. So how many motor units are recruited, we call this recruitment, the number of muscle fibers in each motor unit, and then how often we're stimulating these motor units. You can actually cause a motor unit to generate more force if you stimulate it more often. Okay. Now, basically, the long story short is that the more motor units that are recruited, that means you're recruiting more muscle fibers, which means you've got more cross bridges, which means you've got a stronger contraction. So ultimately, an increased stimulus frequency, what that does is that it causes the release of more calcium. I release more calcium, I form more cross bridges, and if I form more cross bridges, I have more force. Now, as I've said a couple times, this is affected by other factors, and that we're going to discuss later on this week and throughout the semester. And so, at the end of this video, can you do the following three things? Can you define motor units? Can you explain the other known principle? And can you explain how we're able to generate more